Okay, so finding limits that are infinite and limits at infinity. Essentially, we're just finding limits at asymptotes for this lesson. So let's talk about infinite limits real quick. Infinite limits are when you get a number over 0. Okay, so you can get like 2 over 0, 3 over 0, 1 over 0, negative 5 over 0. It doesn't really matter. Then there are 3 cases. Your answer is either going to be positive infinity, negative infinity, or does not exist. Those are your 3 options anytime you get a number over 0. Okay? So kind of just be aware of that as we go through this lesson. All right, so it wants us to graph this real quick. Hopefully you remember how to graph this stuff. It just means we're going to have a vertical asymptote at 2, and we're going to have a horizontal asymptote at 0. This all came from the first semester. Looks like this graph's going to go something like this, and something like this, give or take. Not exact, but good enough for what I want to do. Okay, so we want to find the limit. Do you remember the first lesson how I said that if there's a little minus sign, that just means from the left. So for this guy, I'm just going to find the limit as we're going to the left. Okay, since we're only going one direction, one path, the limit is going to exist. Whether it's going to be a number or an infinity sign, it will be something. Okay, so I'm going through this path from the left, and I'm going to keep going that way because I'm being blocked by that vertical asymptote. So what direction is that heading? Very good. It's going to negative infinity. Okay. For part B, this little notation right here, this is going to the right. So let's go ahead and take this from the right side, and now it's going up and up and up and up and up. And so that is going to be a positive infinity. All right, so those are our situations. Okay, as we're going down here, it says for each function, analytically, find a single real number c that is not in the domain. In our case, it's just going to be a vertical asymptote. And then graphically, find the limit as it approaches c from the left and from the right. So let's go ahead and do that real quick. So for number 2, it's when you set the bottom equal to 0, that's when you get your vertical asymptote. So our vertical asymptote is going to be at 4. Okay, so a quick sketchy poo here. So I'm going to go ahead and graph this. I'm going to get one of these guys. And if you want, you can always type this in the calculator for these examples. I'm not asking you to know how to graph these. It helps if you know how to graph them, but you don't necessarily have to know how to do it. So that's what a graph looks like, and the c value is at 4. This is x equals 4. Okay, so from the right, what's going on from the right? All right, I'll trace it with this thing right here. From the right, I'm going up to infinity. So positive infinity. And from the left, if I'm tracing this thing, I'll make it a little bit bigger. From the left, it's going down, down, down to negative infinity. For the next one, it's got a vertical asymptote at where? Well, you just set the bottom equal to 0, and you're going to get an asymptote at 2. And then we have horizontal asymptote at 0 still. Again, you can use a calculator to graph this stuff. So our c value is 2. Okay, this is what the graph looks like, though. It's a little bit different. If you're lost, just use a calculator. Not a big deal. So as we approach from the right, it's going down. So this is going to be negative infinity. Approaching from the right, or sorry, the left, going up. So it's going to be positive infinity. Okay? Try 4 on your own. You can use a calculator and then hit pause and then get back to me. All right, so the graph of this is going to be at -2. Is horizontal asymptote, and these are actually both going in this direction. So my C value is -2, and then for both strands, both sides, both paths, they're both going down. So it's going to be negative infinity for both of those. Okay? Okay, so for these guys right here, finding vertical asymptotes is when the denominator is equal to 0, and it's not the numerator. So this just means that not a whole. Make sure that our asymptotes are not at a whole. Okay, so what you want to do first is factor and cancel if possible. So real quick, set the bottom equal to 0. The top will never equal 0, so I'm not worried about that. So I'm going to get x to equal -1. That's my vertical asymptote. Set the bottom equal to 0. Not worried about the top, again, because it will never equal 0. So when I set the bottom equal to 0, I'm going to get x equals plus or minus 1. That's my vertical asymptote. For number 7, well, my top can equal 0, so I do want to factor that. So these can factor, and I just need to make sure, just double check that it's not a whole. So factor the top, I'm going to get x plus 4, x minus 2. Bottom is x plus 2, x minus 2. Well, these cancel out. So 2 is not a vertical asymptote, but there's a hole at 2. So I'm really left with setting just the other one didn't cancel equal to 0. So I'm going to get x equals -2 is my vertical asymptote. This is actually not new whatsoever. This is all review. Okay? All right, so finding the limits in these directions. So what I'm going to do right now is for these to make it a little bit easier than graphing them is I'm going to show you just a little bit of a cheat here. Okay? To figure out, oh, is this going to go to infinity or is it going to go to negative infinity? So this is from the left. Okay? If I directly plug this in, the 1, I will get 1 over 0. Okay? That's if I plug it in at 1. So remember what I first wrote about our 3 options? It's either going to be positive infinity, or it's going to be negative infinity, or it's going to be does not exist. Now, this is in one direction, so the does not exist is not going to be an option. So it's really either going to be this positive infinity or negative infinity. So you just need to know, is this thing going up or is it going down? So what I'm going to do is I'm going to pick a number that's super close to 1, and I always just go off by 1/10. So what's a number that's very close to 1? I pick 0.9, and everything I pick is always going to be off by 1/10. Okay, so if I plug in a 0.9 into this function, I'm going to get 1 over 0.9 minus 1. Okay? And all I care about are the signs. So the top is going to be positive 1 over the bottom is going to be negative 0.1. Is that going to end up giving me a positive number or a negative number? That's going to end up giving me a negative number. I don't care about what it is, but what I do know is that it's negative infinity. So do the same idea over here. If I directly plug in a 1, I'm going to get 1 over 0. So I have my options here. It's just from one direction, so it's going to be either positive infinity or negative infinity. Plug in a number that's just to the right of 1, so 1.1. When I do that, I'm going to get 1 over 1.1 minus 1, all squared, which is going to give me 1 over 0.1 squared. I don't need to find that out. I just need to know, is that positive or is that negative? Well, this is going to be positive, so the answer is going to be positive infinity. Okay? Try out 10 on your own, and then hit pause, and then hit play when you're ready. All right, so again, I'm going to get a 1 over or negative 1 over 0 in this case. So I'm going to plug in a 1.1 because it's just to the right. So we get negative 1 over 1.1 minus 1 squared equals negative 1 over 0.1 squared. It's negative divided by a positive, which is going to be a negative number. Now, the reason I want to plug in a number that's close to it and not a number that's far away from it is just in case there's a lot of extra dips and whatever going onto the graph. This is just a safe way of doing it. So 11, it's going to be the same exact idea here. So plug in a 1. What do you get here? You're going to get negative 2 over 0. Okay, so we're going to go to this from the left. So we're going to do a 0.9. So instead of me plugging in a 0.9 here, I just think it's easier if we factor this to be x minus 3. I really think that's much easier because you're going to get 0.9 times 0.9 minus 3 all over 0.9 minus 1. Okay? And that's going to give me, on top, that's going to give me a positive right there, right? So it's going to be 0.9 times a negative 2.1, which is negative, all over a negative 0.1. So the top is going to be negative. The bottom is going to be negative. Negative divided by negative is going to give me a positive. Okay. Same problem, different direction. So I'm going to get a negative 2 over 0. So I know it's going to be positive or negative infinity. So plug in a 1.1. Again, it's easier if this is factored. It's a lot less work. It's 1.1 times 1.1 minus 3 all over 1.1 minus 1, which is going to give us 1.1 times 1.9 negative all over 0.1. So the top is going to be negative, bottom's positive, which means it's going to give me a negative infinity. And then I'm going to get, for this one, I'm going to plug in my 1, and I'm going to get, 0 over 3. This is so simple. This is equal to 0 over 3, because there's nothing there. It's not 0 over 0. It's not a whole. It's not a number over 0. That's great. So I'm going to actually get 0 as my answer. That is my answer. That's phenomenal. Okay. Now, before I do 14, you remember what I originally said, that if it's something over 0, you have 3 options. It's going to be positive infinity, it's going to be negative infinity, or it's going to be DNE. We haven't talked about this DNE yet. This DNE is going to happen when both paths do not match. And I just care about the signs. Are they both positive infinity? Are they both negative infinity? So for this problem right here, I always plug in directly because that's just the easiest thing to do. I'm going to get 3 over 0. Okay? Now, what I need to do is I need to find out what's going on from 1 to the left, which I'm going to use 0.9. And I need to know what's going on from 1 to the right, which is 1.1. Just use those numbers to plug in. If they're both positive infinity, the answer is positive infinity. If they are both negative infinity, then the answer is negative infinity. If they are different, then the answer does not exist. So let's go ahead and plug in a 0.9. So when I plug in a 0.9, I'm going to get 0.9 squared plus 0.9 plus 1, which, do you agree with me that that's always going to be positive on the top? And I'm going to get 0.9 cubed minus 1. Okay, when I do 0.9 cubed, I'm going to get, it's definitely going to be a number that's less than 1. Okay, so the top we can agree is positive. The bottom there, I'm going to say is negative. Right? Because when you do 0.9 cubed, you're just getting a number that's smaller than 1. Right? And you can trust that on your computer calculator if you want. So when you do positive by a negative, you're going to get a negative infinity. From the right, you're going to get 1.1 squared plus 1.1 plus 1 all over 1.1 cubed minus 1. Well, this top is always going to be positive, and that bottom, 1.1 cubed, is that bigger than 1? Yeah, it is. So it's actually going to be positive. So my two paths are different. One's going to negative infinity, that one's going to positive infinity. Since they're different, the final answer does not exist. Okay, so now talking about limits at infinity. So now these are going to deal with horizontal asymptotes. I don't know if I spelled that right. It's embarrassing. I don't know. I'm just going to scroll away from it. Okay, so we're going to graph this. Again, if you just want to use a calculator, you can. I'm not too worried about you being able to graph this right now. It's going to look something like this. Okay, so this is what the graph looks like. So this notation right here, limit goes out to infinity, just means that that's going to be the horizontal asymptote. Okay? So this is going to be the horizontal asymptote to the right. I'm going to write this a little bit nicer. Because it's possible you can have multiple horizontal asymptotes, different values for those. So let's look at my graph right now. To the right, what's going on the horizontal asymptote? To the right, the graph is approaching 3. So the horizontal asymptote is 3. If it's negative infinity, this is going to be the horizontal asymptote to the left. And from the left, it's going to be 3. More often than not, especially for this course, they're probably going to match. but not always. Just kind of be aware of that. For this course, yeah, those are going to match, but not always. Okay, so guideline for finding the limits to find the horizontal asymptote. So if the numerator is less than the degree of the denominator, then the function is going to be 0. And I will go over this technically why this is true. Okay. I'm going to show you the long way to do all of these. I just want to do everything technically correct. There are shortcuts to it, and these are the shortcuts. If the degree of the numerator is equal to the denominator, then the limit is going to be the ratio of leading coefficients. If the degree of the numerator is greater than, then the limit is going to diverge, which means that the limit is either going to be positive infinity or negative infinity. Okay? All right, so they do not want to... okay, we're almost done here. No calculator here. So the easiest thing to do is we want this to be ratios of each other. So you can actually rewrite this as the limit as x approaches infinity of 5x squared minus 2 over x squared. Okay. So the shortcut, and I will show the shortcut for, yeah, I guess I'll just do the shortcut for all of these. So since these have the same power, you're just going to get scenario 2. So the degree of the numerator is equal to the degree of the denominator. By degree, we mean the highest degree. So the highest degree on top is a squared. The highest degree on the bottom is also a squared. So that means that this is going to equal a 5. Okay, for 17, as we do this one, these are going to be the highest degree on top is a 1, highest degree on the bottom is a 1, which is scenario number 2 again. So since this is scenario 2, we're going to take the 2 divided by the imaginary 1 in front, which is going to give me a 2. Number 18, the degree on the top is a 1. The degree on the bottom is a 2. So this means that the degree is higher on the bottom, which means it's going to be scenario number 1 up here, which means the answer is going to equal 0. Now, I will just show you technically why this is true on all of these. I'm going to just kind of work through number 19, doing it technically correct, just so you can kind of see that. But then if you're totally comfortable, the shortcut will always work here. So for number 19, what you want to do here is you actually want to technically, if you divide everything by the highest power, then it will kind of come out nicely. So this is going to be the same thing as limit as x approaches infinity. So if you divide this one, we're going to get 2x squared over x squared plus 5 over x squared all over 3x squared over x squared plus 1 over x squared. And this right here scares a lot of people. I'm sure you're thinking right now, what the heck is he doing? Why is he doing this? Again, I'm just showing you technically why these shortcuts work. Okay? So for the first one, for this top one right here, x squared cancel out. I'm left with 2. So 2 plus 5 over x squared. All over this next one, those cancel out as well. So I'm going to get 3. plus 1 over x squared. Okay? Now, since for these two right here, since the bottom power is larger than the top, those go to 0. So I'm going to get 2 plus 0 over 3 plus 0, which is 2/3. Which you easily could have done right off the bat, noticing, okay, these are the highest powers, divide the coefficients, boom, you get 2/3. But that's just why. If you're a little sketched out by that, and, well, I don't know what to tell you, really. It's what we do in calculus. Though obviously, we use the shortcuts as well, but I just want to show you technically why that works. Okay, so for this one right here, for number 20, going back up here to show you the 3 scenarios there, the highest power on the top is a 3, and the highest power on the bottom is a 2. So we're in scenario 3 here, so this one is going to diverge. So now it's either going to be positive infinity or it's going to be negative infinity. Okay? So easiest way to do this one is to really just plug in a high value and just to see, is it going to be positive or is it going to be negative? And you can just look at this one right here and just tell that the top is always going to be positive. Okay? No matter what you do, the top is always going to be positive. The bottom is always going to be positive as well. Again, we're plugging in a positive numbers here. So this answer right here is going to be positive divided by positive, which is going to be a positive infinity. Okay? $21. Again, you have another situation here where the top is larger than the bottom, so this is going to diverge. So now is it going to positive infinity or negative infinity? This one's a little bit tougher to see what's going on. This one right here, this is going to be positive as we go to a large number. And you're probably like, well, how do you know that? Well, isn't the top just a parabola? And aren't you going out to a large number on the parabola to the right? So that's how I know the top is positive. The bottom is a line that's going to the positives. Okay, so that's how I know it's positive divided by positive, which is going to be positive infinity. Now this one's going to be a little bit different. Same problem here. It's going to diverge, but the difference is we're going to negative infinity now. Okay? So the top, I already said that, it's like a parabola. It's always going up and up, so it's always going to be positive. Okay? So no matter what negative number we put in there, it's going to be positive. But for the bottom, what's going to end up happening here is if I plug in a really large negative number, like, I don't know, 100, it's going to turn out to be negative. Reason is because this is a line with a positive slope. So what's happening to the left? Well, it's going to be negative. So I have positive divided by negative, which is going to give me a negative infinity. Oh, here's a fun one. Well, in case you don't know, this is what sine looks like. Going on forever and ever, right? It's going to keep on going. So what happens at infinity? We talked about this on the first lesson, that this actually oscillates. So what happens when something oscillates to wherever the limit is approaching? It actually does not exist. Because we don't necessarily know if it's going to end up at 1 or negative 1 or anything in between. All right, so for this one, mean, if we like doing that, and the power on the top is positive, so this is going to diverge. Okay. Now plug in a negative number. And plug in a negative number, it's going to get cubed, so it's going to stay negative. So it's going to be negative infinity. If you're totally lost, be like, all right, well, what's negative 100 cubed? Well, that would be negative... What is that, 1 million? 100,000? I don't know. I don't really... You'd think I would know these things. I know it is a million. I just can't write enough zeros. Okay, so that one's going to diverge to negative infinity. The last one, this is a fun one. Remember how I said there's some situations where there are two different asymptotes? Well, if you were to go ahead and graph arctan, there's actually asymptotes top and bottom at pi over 2 and negative pi over 2. The graph looks like this. So what's going on at positive infinity? You would get pi over 2. What if I asked another question, number 26? What's the limit as x approaches negative infinity of arctan? Looking at this graph, at negative infinity, this one would be equal to negative pi over 2. All right, and that's all you need to know about limits at infinity.